Welcome to the deep dive. Okay, so if you're looking to build like a serious foundation in tech, especially the stuff holding the internet together, you've definitely seen those three letters, CCNA. Everywhere.
You're right.
And the sheer amount of info out there on the Cisco Certified Network Associate, well, it can honestly be paralyzing.
It really can. Information overload.
Exactly. So our mission today, let's cut through all that noise. We want to give you the essentials on the CCNA 200-301 exam and, map out a clear path for you.
Yeah.
Building that foundation.
Yeah.
Okay, let's unpack this.
And, it's arguably the most important starting point for networking. It's kind of the baseline for roles like network engineer or maybe an NOC engineer.
NOC being the Network Operations Center.
Right, exactly. The folks monitoring everything. Or even a system admin, managing servers and making sure they talk to the network.
Okay.
And the key thing is these fundamentals, they stick with you. They're transferable skills. Even if you pivot later into, say, cloud or DevOps.
That mix of development and IT operations.
Yeah, that core networking knowledge, it's still absolutely essential. You can't escape it.
So it's more than just knowing Cisco gear. It's like learning the universal language of how data moves.
Precisely.
We saw this analogy comparing it to maybe 10th grade networking, like the solid general education you need before you specialize further, maybe with CCNP or DevNet. Is that a fair comparison?
That's a really good way to put it, actually. Yeah. The CCNA, Cisco Certified Network Associate, it basically proves you get the fundamentals of how data travels.
Okay.
It confirms you can handle network basics, routing and switching concepts, security fundamentals, IP connectivity, and now, which is important, a bit of automation and programmability, too.
Right, the modern stuff.
Yeah. It shows, how devices communicate, how data gets around, and maybe most importantly, how to fix things when they inevitably break. Troubleshooting.
That definitely sets the stage. So we get the skills it validates.
Yeah.
Now let's talk about the actual test, the crucible, as you might say. If you're aiming for this, you need the practical details. What's it really like sitting for the Cisco CCNA 200-301 exam?
Right. The exam, 200-301 specifically, it's a real test. It pushes your knowledge, your speed, and your actual hands-on ability.
How many questions are we talking?
You're looking at roughly 100 questions, give or take a few, and you only have 120 minutes to get through them all.
Wow. Okay. 2 hours for 100 questions?
Yeah, and the types of questions vary. You'll see standard multiple choice, of course, drag and drop questions where you match terms or concepts, and then the big ones, the simulation labs, the sims, where you actually configure virtual routers and switches.
Exactly. In a live simulated environment, it's not just theory and passing. You need around 825 points out of a possible 1,000.
So roughly what percentage is that?
Most sources, including Cisco unofficially, suggest you should aim for about 80 to 85% correct on your practice material to feel confident going in.
Hold on. 100 questions, 120 minutes? And complex simulation labs where you're typing commands, that sounds incredibly tight on time. It is. The time pressure is probably the biggest hidden challenge.
So how do you manage that? Is there a trick? Like, should you skip the sims and hope to come back?
Oh, definitely not. That's a great question, actually. Skipping the sims is usually a recipe for failure. They're weighted quite heavily.
Oh, okay.
The real key is you have to know the multiple choice stuff cold so well that you don't waste precious seconds deliberating. You answer the MCQs quickly, accurately, and bank that time.
Bank time for the simulation.
Exactly. You need to carve out, ideally, at least 15, maybe 20 minutes, specifically for those hands-on labs. Practice exams are crucial for getting that timing down.
Okay, that makes sense. That shift from just knowing it to applying it under the clock.
Yeah.
That's probably where people get tripped up.
Absolutely.
So if we need to be smart about study time, how does Cisco actually break down this massive topic? What's the roadmap? I think there are 6 main areas, right?
Yeah, 6 core domains. And knowing the weighting, the percentage for each, is super important for focusing your study.
Okay, so let's walk through them. What are the heavy hitters?
All right. First up, network fundamentals. This is 20%. Think OSI model, TCP/IP, cables, ports, basic protocols. The real groundwork.
Got it, 20%.
Second, also 20% is network access. This gets into things like VLANs, virtual LANs for separating traffic trunking between switches, Ether channel for bundling links, and some wireless basics too. How devices actually connect to the network.
Another 20%, so 40% just on fundamentals and access.
Right.
Then comes the biggest one, IP connectivity. This is 25%. This is the real engine room, like you said earlier.
Right.
Routing protocols, OSPF, primarily static routes, IP addressing, subnetting, how data actually gets from point A to point B across different networks. You absolutely have to nail this section. Spend the most time here.
25% on IP connectivity. Makes sense. What's next?
Fourth is security fundamentals, coming in at 15%.
Yeah.
Basic device hardening, securing ports, access control lists, AZLs to filter traffic, understanding VPN concepts.
Yeah, 15% security. Fifth, we have IP services. This is 10%. Things like NAT network address translation, which lets private IPs talk to the internet, DHCP for automatic IP assignment, NTP for time synchronization, kind of the support services that make networks usable.
Right, 10% for IP services. And the last bit.
And finally, the last 10% is automation and programmability. This is newer, reflecting how networks are managed now, understanding concepts like REST APIs, JSON data, and tools like Ansible or Puppet at a very basic level.
Interesting. Even just 10% on automation shows it's not just about configuring one box at a time anymore.
Precisely. It's shifting. You don't need to be a master programmer for the CCNA, not at all, but you need to grasp the concepts, understand what network automation is, and why it's important.
That breakdown is super helpful, especially knowing IP connectivity is the quarter chunk. So that leads us right into the how. We know the what. How do you actually prepare? What are the concrete steps, the tools you need?
Okay, yeah, the practical side. It's kind of a three-pronged approach, I'd say. You need good study materials, you need practice tools, and maybe most crucially, the right mindset.
All right, let's start with tools. What's essential? Number one, non-negotiable. Cisco Packet Tracer. It's Cisco's own network simulator, and it's completely free. Free. It's huge.
It is. You download it, you can build complex virtual networks, routers, switches, firewalls, PCs, and practice every single command you need for the exam without spending a dime on hardware. It's indispensable.
Okay, Packet Tracer first. What about books or courses?
For structured learning, you want reliable sources. The official stuff is usually best, so books from Cisco Press or following the curriculum on the Cisco Networking Academy website, they align directly with the 200-301 exam blueprint.
Stick to the official sources. Makes sense.
Yeah.
And practice exams.
Definitely. Once you think you know the material, you need to test yourself under pressure. We often hear good things about tools like Boson XM. It's a third-party simulator known for being, frankly, harder than the real exam.
Oh, interesting. So it over-prepares you.
Sort of, yeah. If you can pass Boson, you're likely in very good shape for the actual CCNA. It prepares you for tricky wording and tough simulation.
Okay, materials, Packet Tracer, practice exams. You also mentioned a shift in mindset. What's that about? Is it just about buckling down and studying?
It's more about how you study. You absolutely must focus on understanding the concepts, not just memorizing the commands.
Can you give an example of that?
Sure. Like, anyone can memorize the command show uproot to see a router's routing table. Easy.
Right.
But understanding means knowing what administrative distance means in that output. It means being able to look at two different routes to the same place and know why the router chose one over the other. Maybe one came from OSPF, one's static, why is one preferred?
So it's the why behind the command, not just the syntax.
Exactly. The simulation labs will test that why. If you just memorize commands, you'll likely freeze up when something unexpected happens or you need to troubleshoot. Understanding the underlying principles lets you figure things out. Memorizing keystrokes alone just won't cut it.
That's a really critical distinction. Okay, let's make this even more concrete.
Yeah.
You mentioned Packet Tracer. Can we guide the listener through like the very first simplest lab they should do right now just to get started?
Absolutely. This is like the hello world of Packet Tracer. Your goal is just to get the software installed and prove your basic environment works.
Okay, step one.
Download Packet Tracer from the Cisco Networking Academy site, netacad.com. You'll need to create a free account, get it installed.
Easy enough. Then what?
Open it up. The interface looks like a blank canvas. Find the end devices icon, usually bottom left. Drag two generic PCs onto the workspace. Just click and drag.
Okay, two PCs on the screen.
Now find the connections icon, looks like a lightning bolt. Select the copper, straight through cable, usually a solid black line. Click on PC 1, choose Fast Ethernet, then click on PC 2 and choose its Fast Ethernet. You'll see a cable connecting them.
Got it. Two PCs linked by virtual cable. I'll make them talk. Yep. Click on PC 1. A window pops up. Go to the Desktop tab, then click IP configuration. Keep it simple. Choose static and type in an IP address, 192.168.1.1. The subnet mask, 255.255.255.00 should fill in automatically. Okay, PC1 is 192.168.1.1.
Close that window, Click on PC2, go to Desktop, IP Configuration, Static, assign it 192.168.1.2 with the same subnet mask. Close that. No routers, no switches needed for this first step, just a direct connection.
All right, both PCs have IPs on the same network. How do we test if it worked?
Type the command ping 192.168.1.2 and press enter, pinging the other PC's address.
Exactly. If you see a line saying reply for 192.168.1.2, then success. You've just configured basic IP connectivity and tested it. Your Packet Tracer lab is working and ready for more complex stuff.
And if it doesn't work? Well, then you've already started troubleshooting. Double check the IPs, the subnet masks, make sure the cable link lights are green in Packet Tracer. It forces you to learn those little things. I remember spending like an hour once trying to figure out why two routers wouldn't talk, only to realize I'd forgotten to type copy running config startup config on one of them. Simple mistake, but the simulator teaches you those practical lessons.
That's brilliant. So accessible. It really lowers the barrier to entry, takes away some of that intimidation factor around networking gear.
Definitely.
Okay, so let's just quickly recap the main points for you, the listener. The CCNA 200-301. It's your essential networking foundation, building skills that are valuable pretty much anywhere in IT.
Mm-hmm.
The biggest chunk of the exam, your main study focus, should be IP connectivity that's 25%.
Absolutely critical.
And your best friend for hands-on practice, the tool to bridge theory and practice, is Cisco Packet Tracer. And it's free.
Couldn't do it without it, really.
So putting this all together gives you the confidence, hopefully, not just to pass the exam, but to actually step into a real network environment and, understand what's going on.
Exactly right. You're building a skill set that truly opens doors. And, if we connect this to the bigger picture down the road, we could trace how a single message weaves its way through a huge, complex network, the whole journey of data.
That sounds fascinating. But for right now, I want to leave you with this thought to chew on. You just learned the steps, the clicks and commands, to make two imaginary computers in a simulator talk over a single virtual cable using ping.
Right. Now think about what it takes for that same simple ping command to travel not just across one cable, but maybe across an ocean, bouncing between routers on different continents, navigating a network connecting billions of devices, just to get a reply back. That's the incredible scale of the world you're starting to explore.